Welcome, everyone. My name is Sam George. I'm here today to talk about Azure IoT. So this, just so you know what you're in for, this is a broad overview talk of everything that we're doing in IoT and how you can take advantage of it. So I will cover things in great detail or in breadth. We have lots of talks this week that go into very, very deep detail. But I'm here to be your tour guide to explain everything that we do in IoT, what we offer, and I'll talk about some of the great things that we have in preview right now that you can take advantage of. So first, we've been in market for some time now, and one of the most exciting parts of my job is watching how customers are benefiting from this. We have some great stories. There was a really fun one that came out earlier this year from Hershey's, where they've actually optimized their Twizzler production plant using Azure IoT. One of the challenges that they were facing was if you're manufacturing candy and you put it into a bag and that bag says it weighs 3 ounces, it has to weigh 3 ounces at least, can't weigh less. And what they were hitting was a tremendous amount of variability as they would mix up this giant batch of licorice, then they would start extruding it. And there was a lot of variability in the individual weight of each Twizzler. And so that produced a little bit of a manual process that they had to do to make sure that there was always enough for a bag. And so what they did is using Azure IoT, they instrumented their entire production line. They used Azure machine learning to find what were the predictive things that would indicate when they get consistent weights across the Twizzlers as they were being produced in these 8-hour factory runs of licorice. And they were able to dramatically reduce the amount of variability in the weights of these things so that they could decrease the amount of overage they were having to put in the bags. Anyway, it wound up being quite a nice savings for them, and now they're applying that to their chocolate lines. Tetra Pak is a really innovative on-demand manufacturer, and so they can produce different manufacturing plants very quickly as their customers need new things manufactured. And what they've done is they've gone and applied predictive maintenance to all of the parts of the factory line. And they're able right now for these devices that are all connected, they're able to save about 48 hours for each packaging line, which saves about 30,000 euros per customer. So there's some pretty significant savings that are going in. Royal Automotive Club, sort of like AAA here in the States. They have created a connected field assistance program, and using their own vehicles and optimizing their own fleets, they've been able to save about $1.8 million a year just in fuel savings and just from avoiding crashes. So there's some great examples of how IoT is helping in the real world. And there's a lot of customers, and these are just the ones that have given us permission to put their logos up. There's a lot of customers that are already benefiting from Azure IoT in production today. So what I thought I'd do is I'd spend the time talking about what it is that is unique among all these IoT solutions, what constitutes an IoT solution, and then where Azure IoT has an offering for each part of that. At its simplest form, almost its most remedial form, IoT solutions all have a very common pattern. There's things that are being monitored, and this is often not the device that's monitoring it that you're interested in. It's what's being monitored, whether for Hershey's, whether it's that Twizzler production line, whether for the Royal Automotive Club, whether that's the individual service assistant vehicles that are being sent around to help people. There's insights that you gain from those things. And the whole idea of IoT, obviously, is something that you didn't have visibility into before, you can now have visibility at much higher frequency, often in real times. And then there's insights that you can gain from those, from that real-time nature of that data collection. And then there's actions that you take as a result of those insights. And so having these three present, what we find is that these three areas are always present. And this pattern of things, insights, and actions is broadly applicable. When you look at the world of IoT right now, there's a lot of great things that are happening. I'll pick on a few here. For example, vaccine delivery is being companies are actually keeping vaccines secure, keeping them safe, and assuring quality and purity by keeping them at the right temperature during transportation, by knowing where they are, by seeing whether there was too much vibration that occurred to the packaging as they were in transport, and then knowing that ahead of time before they find out and stock a hospital with vaccines that aren't well. There's connected dogs. That is a real scenario that's built on Azure IoT by a company called GPAWS. There's a solution that they built with a connected collar, and it helps you understand how much exercise your dog is getting. It's kind of a fun scenario. Connected cows, I think we've talked about that a few years ago. Connected factories and buildings, connected engines, a lot of predictive maintenance that is happening across the industry. And all of these, what's fascinating about these is when you step back, they all share a very common architecture and a common pattern. Under the covers, they're connecting to IoT Hub. They're using stream analytics for processing events and looking for patterns in their data. They're using Azure Machine Learning for predictive analytics. It's very similar. The only thing that's different is the type of device that's being connected to and the type of insight that you're after. So these projects can be pretty complex. There's a lot of services that are involved in an IoT solution. There's cloud gateways, there's storage, there's analytics, there's business process integration, there's dashboards, there's mobile notifications. There's a lot to these IoT solutions. It can be difficult to maintain cohesive security across them. It's hard sometimes to connect that to existing business processes. And then one of the things that we see is that if not done right, it can be really challenging to scale over time. An IoT solution with 100 devices or 1,000 devices looks a little different than an IoT with 1 million or 10 million or 100 million devices. And a more realistic view in IoT is what you see here, where there's a lot to consider in an IoT solution, including end-to-end security, including things like fault tolerance, including data sovereignty and privacy and security. There's a lot to consider. And so a big focus of ours for the last couple years now has been on simplifying IoT. Microsoft has a history of taking complicated technologies and making them straightforward, making them easy and broadly available. And that's a big focus of ours. For the last couple of years, we've been building from the ground up. There's a bunch of foundational services that we've been building. And now we're really getting to the good stuff. We're getting to a lot of the solution accelerators. We're getting to a SaaS offering soon that make it very, very easy to get going with IoT, that don't require deep expertise in order to benefit from IoT. So the ways that we're focused on simplifying IoT is as follows. The first is around making it easy to build secure, scalable solutions all the way from device to cloud. Once you have one of those, what we found is that it can be challenging to simply add devices to these solutions. When you're talking about the scale of IoT, when you're adding 10,000 devices a month to an IoT solution, turns out that can become the bottleneck, not the solution itself. And so we're solving that with device provisioning, and I'll explain what we're doing there. To manage devices at scale, at the scale of IoT, if you're driving around and messing with individual devices for most things, you're not having a great IoT experience. There's a lot in IoT where you can save dramatic amounts of money by simply being able to remotely diagnose something and take the right tools to fix it the first time. Making it easy to find insights from IoT devices. One of the things I'm going to be showing you is a new offering that we have called Azure Time Series Insights that dramatically lowers the bar in terms of what's required to find insights from IoT data, from the realm of data wrangling and machine learning, all the way down to the realm of the average knowledge worker. Making it easy to push intelligence down to devices. Earlier this year, we announced a set of new capabilities to our Azure IoT Edge product, which allows you to run machine learning, stream analytics, Azure functions, and even cognitive services right out on IoT devices. And all of this makes it easier to benefit from IoT. So first, let's talk about solutions. So we have a solution already in market today, a set of solutions called the Azure IoT Suite. The whole idea behind the IoT Suite is that we have this rich set of services across Azure, and there's a lot of them that are helpful in an IoT solution. And what we heard loud and clear from customers was that how do I assemble these? Which ones do you recommend? Which ones do I use? How do I get started quickly? When we introduced this 2 years ago, what was typically happening, we did a pretty elaborate influencer study to find out how were IoT solutions being developed. And what we found is that it was typically, within enterprises at least, it was typically line of business decision makers that were greenlighting these things. And often they would go and hire a system integrator, and that system integrator would charge them a fair amount of money, and it would take a bit of time to get that rolled out. And that was just if they wanted to evaluate IoT and whether IoT could have a benefit in a specific use case. And so what we did is we made that much, much easier to get started with the Azure IoT Suite. You simply push a button, give us your Azure subscription, and pick a region, and we go and provision a set of services and provide a default application that makes that work end to end. We're also working on Microsoft IoT Central. It'll be in public preview this year. And so Microsoft IoT Central is a SaaS offering for IoT that makes it really, really dramatically easy to get started. And these two are very complementary. One's really an accelerator built on PaaS services. The other is a SaaS offering, and they're built on the exact same platform services. And so when you look under the covers, what you see is that they're using IoT Hub, Azure Stream Analytics, Azure Time Series Insights, machine learning, and logic apps, and more. And so the reason why we're building it on this is so that every single benefit that we add to these underlying services winds up getting surfaced in both offerings. So as we add new rich capabilities to IoT Hub, it's automatically available in Microsoft IoT Central as well as the IoT Suite. And same goes for things like Time Series Insights. And so we're building on the exact same thing. The real big difference is that with Microsoft IoT Central, you'll be able to simply provision an application, connect devices to it, create operational rules, and trigger business process integration, all without writing any code. It's configuration only. We'll have extensibility points for code integration, but you won't have to write any code, and you won't have to write any code to scale the service. And so if you're adding 10,000 devices or 100,000 devices or 1 million devices, we will automatically scale the applications up as we go. And with Microsoft IoT Central, we will wear the pager. We're the ones that keep the applications running, and at the same time, we still ensure it's your data, it's your solution, and it's safe with you. And so if you think about sort of a double click between these two approaches, about how you would pick between these two, the primary usage for the Azure IoT Suite is really around custom solutions, where you need every last amount of capability that Azure might offer, and you're going to build a highly custom solution. And one of the reasons why we introduced, or why we're introducing Microsoft IoT Central is because after being in market a few years, what we found is that there's a lot of IoT solutions that are fairly straightforward, that really are meet the 80% case where you're monitoring something remotely, you're setting operational rules on telemetry that you're observing from those devices, and then you're triggering some action. And this is a very common pattern, and so Microsoft IoT Central really addresses that. From access to underlying services, with the Azure IoT Suite, once we provision it, you can still get to every single service that it's built on. So you can open up the Azure Management Portal and you can get to the IoT Hub. You can go get to the Stream Analytics instance and things like that. And then you can replace services to meet your needs. With Microsoft IoT Central, that's all fully encapsulated because we're managing all that. And so we provide APIs that allow you to use these services, but we maintain the entire application suite. And then as far as flexibility, the highest flexible option will continue to be the Azure IoT Suite. Microsoft IoT Central will have a medium amount of flexibility based on extensibility points that we put in. And those will become more and more rich over time. And then the skill level that's required with the Azure IoT Suite, it's actually pretty straightforward to get going. But if you want to customize, it does require cloud solution development expertise. Microsoft IoT Central will not require cloud solution development expertise. It'll be a configuration-only platform. You'll be able to simply connect devices to it and get going. And then finally, the Get Started experience with the pre-configured solution. Both of these are very, very quick to provision. The Azure IoT Suite provisions in just a few minutes. Same thing with Microsoft IoT Central. And so they're both very easy to get going. So solutions is a big focus of ours, and both of these are really focused on horizontal offerings. And so there's not for example, there's not an Azure IoT Suite fleet management solution, because that's highly differentiated, and there's partners and customers that have very specific requirements for customization for those. And so we provide this horizontal accelerator that makes it easier to get started, and then partners can specialize both of these offerings. So one of the things we're announcing this week is a new update to the IoT Suite's remote monitoring solution. For those that are familiar, the Azure IoT Suite remote monitoring solution is open source, just like all the other Azure IoT Suites, pre-configured solutions. And so we've redesigned the user experience, number one. And so it's a much more pleasing user experience for those that have tried the first one. And this rich UI is pervasive across the entire experience, from device management to setting rules and alerts and things like that. All of this is on GitHub. And will be when this is available in about a week. All of this is on GitHub, and it's free to modify. And so if you decide something like this is useful for you and you want to take this to production, you're absolutely free to do so. One of the things that we've done with this as well is we've introduced a new microservice-based architecture. And one of the things we heard loud and clear from customers was that it was too hard to customize the original IoT Suite. And so we've created a new microservice-based solution. Under the covers, what it uses is a Kubernetes cluster with a bunch of microservices that are written and deployed into that Kubernetes cluster. And we actually offer two different versions of this. We offer a Java version as well as a .NET version for Java developers out there who are feeling left out of the original Azure IoT Suite, which was a .NET one. So all of these microservices are just what that says. They're microservices. And so it's very easy to remove the microservice for stream processing and put in one for the stream processing system of your choice. For example, if you want to use Spark streaming, very, very straightforward to do. Stores data and logs data into Cosmos DB, has a web application secured with Azure Active Directory, and all of this will go live in about a week. Now, our existing connected factory, one of the things Microsoft really focuses on is on the commercial side or the business-to-business side of IoT. Because there's a lot of customers with some pretty significant needs in this space, and there's also huge amounts of optimization that they can apply to commercial environments. And a big thing that we've heard feedback from is about supporting connected factories and supporting devices that speak the OPC UA protocol. And so earlier this year, we introduced a new version of the Azure IoT Suite, a new pre-configured solution called Connected Factory, which makes it very easy with a few clicks to connect to on-premises OPC devices and to take all of that data and import it into Azure Time Series Insights in a live fashion. You can even control the OPC devices and send supervisory commands to them as well. So that's already available. I'm going to talk a little bit more about Microsoft IoT Central. It's really geared towards three personas. The first is builders, and builders are the ones who actually customize or verticalize an application. And so it includes a full builder's experience so that I can create a new application that might be geared towards fleet management or medical vaccine tracking or whatever the specific IoT solution is. I can create all the right UX for it, save it as a template. I can create device models that explain which types of devices I'm going to be connecting to, what's the telemetry that they send, what are the state changes that they make, what are the alerts that they raise, and things like that. I can define rules, so I can say, I'm looking for this telemetry or this state change, and then I can define actions as a result. What are the actions that I want to perform? And that can be a rich set of business process integration options, like open a Salesforce record or a CRM record and things like that. There's administrators who take these applications and provision them, and then they can give access to different users for the application. They can assign other administrators, they can assign operators, and then there's operators, and they're the ones typically that are operating the IoT solution. So for example, you might have an operator for that medical vaccine that's tracking vaccines as they arrive in hospitals, and they're able to view that and watch these products in real time. So there's a couple other ways that we've been focused on simplifying IoT. One of those is our Azure IoT Hub service. So the Azure IoT Hub service has been generally available now for almost 2 years. There's a tremendous amount of features that we've added to it. I'm going to highlight a few of them here today, and we've got some sessions that go into a lot of depth on this. And then we just introduced the Azure IoT Hub device provisioning service, and it's a second service that helps accelerate device provisioning, and I'll explain in depth what that looks like. So for the Azure IoT Hub, we've been focusing on a rich set of services across a number of areas. Number one is around that bidirectional communication between devices in the cloud. As some of you might know, we support HTTP, AMQP, as well as MQTT. You can use IoT Hub to send telemetry, receive commands, and even do device management. So I'm going to talk in a minute about the support that we added for device management with device twins and queries and jobs. We focus a lot on enterprise scale and integration, making this a very robust service that can scale to billions of messages, that can scale up and down. We've added declarative message rules, and I'm going to cover what that looks like so that you can automatically route inbound messages to the correct backend system. And then we've integrated it fully with Azure Monitoring, Azure Resource Health, as well as configuration management. And then finally, we focused a lot on security with the Azure IoT Hub and continue to. So we just recently added X509 support. We already have full TLS support, so we only support TLS protocols. We added support for IP whitelisting and blacklisting, so you can narrow the IP addresses that you receive commands from an IoT Hub or that you can communicate outbound to. And implemented all sorts of rich capabilities to enable things like firmware and software updates to keep IoT devices secure. So let's talk about some of the ways that works. So device management, so we added device management to all of the worldwide IoT hubs last November. And when we did, what we did is we introduced a new concept called Device Twin to IoT Hub. So let's take that example where you've got a set of different devices out in the world, and they're connected to the IoT Hub in a solution in the cloud. The way device twins logically work is that they maintain a digital copy of that device, and more importantly, the state of that device. The way that works is that there's a digital twin for each. So we've updated our SDKs to have digital twin support, and then Azure IoT Hub has digital twin support. And then you can perform queries, find device twins that meet a certain criteria that you're interested in, and then run long-running jobs on those. And this is enabling technology for updating software, firmware, and configuration. So the way that it works is that there's a couple interesting properties, and then there's a capability called methods. So desired properties are something that you can set in the cloud and are replicated down to the device. They're read-only down there. So for a desired property, you do something like set, hey, this device, I want you to set your operational RPMs between this value and that value. And you simply set that on the device twin in the cloud, and that's automatically replicated down to the device. The device gets notification that a desired property has changed, and typically what it'll do is it'll turn around and set its reported property. And then reported property, which is read-write on the device and read-only in the cloud, is sent back up to the cloud. And the reason why we keep these two separate is so that you can have attestation. You can do queries between the two and find where desired properties not equal to reported properties, where are my devices out of equilibrium. And then there's cloud-based tags, and what the tags are is metadata in the cloud. These are all just name, value, pair, property collections. Metadata in the cloud that you can set arbitrary values on. So for example, if we were doing device management in this room, and I wanted to tag all of the devices in it with this conference room, I could just do that in the cloud. And if I decide to take one of those devices and move it to another room, then I would just update its tag. And the device doesn't know about it or really need to know about it. It's really cloud-based metadata. And then the other capability that we introduced was this notion of methods. And what a method is it's a cloud-based request response. So you initiate a request response from the cloud, it sends a command down to a handler on the device, and then the device can return a payload. So you can use this for things like, hey, I want to know this telemetry field, or hey, I want you to go into diagnostics mode, or I want you to do anything that requires immediate attention. And then on top of all of this, there's jobs that can broadcast changes to device twins and changes to and method invocation. So last year we added message routes, which are like inbox rules to IoT Hub. And since then we've been adding more. I'm going to talk about what we've done there. So the way message routes works is, if you remember email before inbox rules, all of your email came to one folder. And then you were the inbox rule, and you would drag it to different folders, and it was really a pain in the butt. And today, you can simply set up filtering rules, and that automatically routes to different folders. That's what IoT Hub message routes are all about. And what we saw early on was that people were building IoT solutions. They had an IoT hub, and then they were building routing logic in their solution. And the routing logic was listening to the backside of an IoT hub for inbound messages from devices. It was using event processor host, for those of you that know what that is. It was using an event processor host, and then it was turning around and routing to different queues, like an alarm queue or a storage queue or an event processing queue that were part of the solution. And what we found was that, and what customers found was that getting that routing logic right was kind of tricky because in the cases of transient failures or solution upgrades, it was sometimes difficult to maintain state for them. And so what we did is we added that as a first-class feature to IoT Hub. And now you can simply set predicates right on IoT Hub for watching for certain message headers, or even if you're using JSON payloads and they're unencrypted, you can query into message bodies. And you can simply set up standing queries and we'll automatically route to the right endpoint. So let me show you really quick what that looks like. Once I get logged in here. So we have integration for this in the Azure portal, in the Azure Management portal. Switch over here. So if you go into the Management portal for IoT Hub, if you scroll down to under Messaging, you can see routes and endpoints. And what an endpoint is an endpoint you can set think of it as a folder in the email analogy that I was using. Think of it as a folder you're going to be sending it to. But that folder in this case can be an event hub, it can be a service bus queue and topic, it can even be storage now. So we just added storage capabilities. So let's say, for example, that I wanted to create a storage container that every piece of telemetry that comes through IoT Hub is going to get automatically sent to. The way you do it is first you set up an endpoint, and I've already set up a storage endpoint here because it just takes a second. So if I were going to set up an additional endpoint, I would simply give it a name and select an endpoint type. And here you can see all the different types we support: Event Hub, Service Bus Queue, Service Bus Topic, as well as storage containers. So the interesting thing, too, about this is that once I pick an Azure storage container, I can either pick an existing one or create a new one. I have these two sliders. One is batch frequency, and the other is chunk window size. And what that is with batch frequency, that's either you tell us, hey, every 100 seconds or every 720 seconds or whatever period makes sense for you, automatically write that group of telemetry out to storage. Or this chunk size window is once the telemetry payload that you're in queuing gets to a certain size, then write that out. And so if either of these hit first, then we'll automatically write to storage. And we have a little template language here where you can specify what the storage blob name is going to be. And so in this case, it's simply using year, month, date, hour, minute. All right, so once I create one of those, let me just close this. Once I create one of those, to create a routing rule is super easy. So I would just simply go to add routing rule, give it a name, like straight to storage. Pick a data source. And so there's a couple different data sources we support for these routes. Device messages is the ones you would naturally think of. That's anytime a device sends a message to an IoT hub. But we also have a couple others. So we have device twin change notifications, and we also have device lifecycle events. And so if you wanted to route any of those for further processing, you could do that too. So I'll just pick device messages. And then here we have a simple query syntax. And so I can filter. So for example, if I wanted to search for every device with a message header that says alarm and send that to storage, I could. If I want to just search for everything, I just list true. And that will always complete with true. And then I click save. And then, oh, sorry, I didn't pick an endpoint. Pick my storage endpoint. And I click save. And it'll go and set that up. And then as soon as that's been set up, any message that's sent to IoT Hub will automatically go to storage. And I don't have to worry about configuring it or writing an event processor host or anything. Device provisioning. So this animation shows someone manually provisioning devices one by one by one, which is a lot of how device provisioning happens today in IoT. IoT device provisioning is a lot like mobile device provisioning was about 8 years ago, when you would walk into a store and you would buy a phone and someone would have to open it up and turn it on and program it for you. I don't know if you remember that. And then they would test it and then would hand it to you. And today when you buy a mobile device, someone scans a barcode on the outside of it and you walk out of the store. And then when you turn it on, it goes through a provisioning workflow. Well, what's happened when they scan the barcode is they went and registered with some provisioning service for that mobile company, right? And then when the device wakes on, it goes and phones home. The problem with manual setup right now is that it's very error prone. You know, it's easy to misconfigure. And this is something that we heard from our customers as we would sit in project reviews, is that provisioning was becoming a bottleneck, especially when you're trying to provision large amounts of IoT devices. If you're doing it manually, what you really want is to eliminate toil and to automate that and to make it so that your configuration system is done centrally and then applied globally. What IoT has really been needing is this plug-and-play device provisioning, where I can simply turn the device on and it'll phone home and do the right thing. And so for that, we've introduced the Azure IoT Hub device provisioning service. And so what the service is and the way it works is it has a global geo-replicated endpoint that all devices that you want to provision into your solutions can point to. And then that service, you can go and register tenants within it. And so you can have your own little region of that, and you can register devices with it. And so the way that it works, let's say I have 3 different IoT hubs, one in Germany, one in China, one in the United States, and there's a set of devices. So we have our SDK, and our SDK has been updated with the device provisioning service capability. And so you would simply tell it to point to the device provisioning service, and that's it. And then send a credential. And the way it works is then all of this provisioning process is handled in the cloud. You can simply go and register with the IoT Hub device provisioning service a set of device IDs. And then once you have, and the devices wake up, the devices will then phone home to this device provisioning service. The device provisioning service will then register the devices on your behalf with the correct IoT Hub. And there's 3 different ways to control this. One is you can give us a static list of this device goes to this IoT Hub. You can also ask us to geoshard it. So if a device wakes up in China, it goes to this IoT Hub. If a device wakes up in the US, it goes to this one. And then at general availability, we'll also add the ability to call Azure function, and you can decide at runtime when the device provisioning service has been contacted by a device. And at any point, at any rate, once the IoT Hub has been contacted by the device provisioning service, once the device has been registered, then the device provisioning service turns around and sends a credential back to the device as well as a connection string. And then the device disconnects from the IoT Hub device provisioning service and connects to the right IoT Hub. And then it can, using our device management, can initiate firmware software configuration. So it's a really elaborate process. It's actually pretty straightforward, but what it enables is you to preload a device with simply an endpoint and a credential, turn it on, and the rest is taken care of by the cloud, by the workflow that you've built in the cloud. And so if you find a bug and you want to update that, you just update it in one place. You don't have to go around flashing firmware or software in order to get provisioning right. And the Azure IoT Hub device provisioning service is already publicly available, and so it's in public preview. You can go try this out right now. So another big way that we've been focusing on simplifying IoT is in reducing the barriers of entry to finding insights from IoT data. Now, one of the insights that we had very early on is that a lot of IoT data comes in is really time series measurements. And what I mean by time series measurements is that typically what you'll see is sensors that are sensing something at some interval, right? Like it might be measuring RPMs of an engine or temperature of those vaccine cases or all sorts of things. But you're measuring it on some periodic basis in a time series fashion. And a lot of IoT data, and there's a lot of it, is being sent to the cloud that really originates from a time series manner. And what we found is that storing that, querying it, analyzing it, and even visualizing it can be difficult. Now, there's some open source time series stores, which we have customers using, and we very much believe in customer choice. But one of the things that we found is that many of those things were lacking is the kind of rich user experience built on top so that everyday average knowledge workers could find insights from that data, especially when you consider IoT scale. If you're sending millions and millions of data points every hour or every day, or it could be pretty challenging. So you can imagine being blasted by lots and lots of IoT devices. And so what we've done is we've introduced Azure Time Series Insights. This is also available in preview right now, and it'll be generally available soon. The whole idea behind Azure Time Series Insights is it's actually a couple things all in one offering. One is it's a very, very robust time series store that we use internally within Azure to log all of our log analytics from every services. And so we're ingesting lots and lots of data at very high velocity into this store. It's also a schemaless store. So you simply send data to it, and we figure out the right schema. And we watch schema drift over time. If you start sending new pieces of data, we automatically index things. We make it very easy to query across large amounts of data. And then it's also an ad hoc user experience where you can do ad hoc queries across it, search across it, create dashboards, and then those dashboards are live. And they change as the data comes in. So it's a really neat offering. And it really lowers the barrier of entry. So I'm going to show you what that looks like real quick. Hop over here. So when you first load Azure Time Series Insights, there's a couple different concepts. The first is there's a notion of workspaces, and a workspace is a unique, basically a unique store of time series data. And so here I have a couple. I have a connected factory demo that I use, and I also have this simulated manufacturing data from West Europe. The other thing I can do here is I can sort different parts of the data. So I can do things like the last 30 minutes, the last 60 minutes, or I can search for very specific times. So we collected this data way back in April. And so if I select a range from April 1st to May 5th, and then click search, what it's doing is it just loaded 30,477,488 records that fast, which is pretty significant. I mean, this makes it look way easier than it should be, because usually this is a batch job that takes overnight, and it's kind of a pain. And so all of that data, the first thing that you see is not a lot, right? You just see there was some data that was collected. But then I can start using Time Series Insights to explore it. And one of the things I see is that there's a lot of interesting parts of all of this data. For example, there's event source name, there's factory that it came from, and there's type. And so if I click on type and I split by type, I see here's all the different unique types of data that came in, because these are all just name value pairs. So for example, I see type pressure, type temperature, type vibration. And then I can start doing ad hoc exploration of this. So for example, if I wanted to filter on type equals production line load, and then split by factory, now I can see what my factories look like over time. And so I can see some of the factories up here had a high production line load, which is high output. Some of them had a fairly low load. And then I can start exploring what went on. And one of the things I can find as I drill into these, and you can also save queries, is I can look at what was the temperature as the production line load was dropping for this one specific factor. Were there alerts that were being fired? And here I can see visually there were alerts that were being fired. Now, one of the cool things about this is at any point I can simply drag and zoom in. And so now I've narrowed it down to just over 1,000 events. And at any given point, if I want to explore this, I can explore the events. And this will actually bring up all the raw data that's been stored. And so I can see all of this. If I want to just look at factory and the type, and it was just these production line load messages, I can. And then I can look at all sorts of stacked views, so I can continue to add to one view, I can continue to add additional predicates, and each predicate winds up being its own chart that winds up getting stacked over each other. And we maintain all the time synchronicity between each one of these views. So now I can start to see things like when this factory was having alerts and the temperature was dropping, what else was happening in different parts of the data? One of the best parts about it as well is I can go into the split view, where if I want to look at that rich view and look at things like temperature control issues, for example, for the exact same time, then I can compare these two things over the same period. And I can continue adding each one of these, like I can look at alerts by factory, and create operational dashboards. And again, this is all live. So if I set my query to be the last 30 minutes or the last 60 minutes, anytime this changes, the chart automatically adapts. I can create pie charts and graphs and weighted averages, and even do things like, let me just show you this one, to create a heat map. So this was actually looking at different factories. So this is literally, it's a bit of a pun. It's a heat map of temperature. And so here I'm able to see all the different factory machines and their temperature output, but I can see it in a heat map. So this is something where normally, I'd have to be a pretty sophisticated data wrangler to process, 37 million or 100 million events and find insights like this. This makes it really easy. You can just simply go and do ad hoc exploration across it. Now, each one of these views gets persisted at its own URL, and so you can share these with people who you give access to the workspace. And then one of the things the team's working on for general availability, today you can store 30 days worth of time series data. We'll be extending that to a year. The other thing you can do is take each one of these different dashboards and then embed it in Power BI. And so you can just have another area in Power BI, so you can have one operational dashboard. So that's Azure Time Series Insights. And another big focus of ours has been Azure IoT Edge. So for those that aren't aware, there's a pretty typical pattern that you see in IoT, especially in commercial IoT, where you'll have individual devices sending data through an intermediate, like a field gateway, and then that field gateway then storing and forwarding and sending it along to the cloud. So last November, we introduced some gateway middleware as an open source project that at the time we called the IoT Gateway SDK, I believe. We rebranded that Azure IoT Edge. That's already generally available. And what we did at our Build Developer Conference this year is we announced a bunch of new capabilities for Azure IoT Edge. And those are some pretty significant capabilities. And to talk about them and to explain them, it's important to step back for a second and think about the different waves of innovation that are happening right now. Everyone's familiar with cloud, and then there's IoT. And IoT we define as being able to process or sense the real world in real time, accept telemetry and manage devices. And what Edge is, as it's really starting to be defined, is to be able to take that intelligence that was normally running in the cloud and to push that back out onto IoT devices. Because if you think about it, as IoT really gets going, and you've got billions of devices sending trillions of messages, there's a lot of data that doesn't need to be sent to the cloud. There's a lot of data that can be pre-processed on the edge, and in fact should be. And there's a lot of times where there's a strong need for it to be. And then you've got AI that's happening right now. And so this is a platform that we're using for AI as well. So we'll be able to enable to push cognitive services to run out on the edge as well. And the important thing that we're finding is that it's not just about being able to place a workload on the edge. That's fairly straightforward. The more important thing is to be able to manage it once it's there. And so I'm going to talk about how we're solving that. So if you step back and look at IoT in the cloud and on the edge, IoT in the cloud is really important for things like aggregating global data, remotely managing devices, device provisioning, and those kind of operations. IoT on the edge is a really appropriate workload for doing things like low latency tight control loops. Let's say, for example, you're processing something from machine and you need to decide whether it needs to be shut down or whether to send an SOS because the machine needs servicing. If there's a local network interruption, you want that logic to keep running. And so IoT on the edge is an important part of the IoT puzzle, being able to put compute right where data is being generated. Because data has gravity, and it's often easier to move compute to where data is than to move data to where compute is. Now, the interesting part and the really important part about this is to be able to have symmetry between the two. Because IoT on the edge is already being used right now, right? People are paying systems developers to go build custom logic that runs out on devices. The interesting thing is to make it so that I can develop intelligence in the cloud, and then to be able to run that either in the cloud or on device, and to decide where I want that workload to run so that I could have symmetry between the two. So if I look at a normal IoT pattern where you've got things and they're sending devices or sending data to the cloud, you're finding insights, a lot of the times you're taking action, and sometimes in real time, you're sending commands back down to the device. Especially the example of I have a machine and I'm protecting it with some predictive model. Like I'm shutting it down from a pending failure. The pattern with edge is you're still doing that same cloud loop where you're still storing data for historical reasons and things like that, but you can do it on a much lower latency. You can do store and forward, for example. You can batch up a bunch of data. You can do pre-processing, and then you can do bulk upload. And then what you can do is you can take those insights and actions, that cloud intelligence for insights and actions, and run it in a local control loop right on the device itself. And so for this, we introduced these new capabilities for IoT Edge. At a high-level topology, the way it works is that you can have IoT devices connected to IoT Hub. You can have Azure IoT Edge devices connected to IoT Hub. And of course, you can use it in gateway configuration and connect to multiple devices downstream. And the details of this, if you blow up Azure IoT Edge and look at what's inside, it's actually several things. Number one, we use container-based workloads. And so we use containers, Docker-compatible containers, for portability between cloud and device, number one. Number two, we're teaching all of our different services, and we're starting with Azure Services, Azure Functions, and Azure Machine Learning and Cognitive Services to export functionality into Docker-compatible containers that can target Azure IoT Edge. So the first thing Azure IoT Edge has is a device twin for the device. And so you can use this to manage the actual device. Because again, this is a device you have to manage software firmware configuration on. It has local storage, it has a container management system, and it also has its own little IoT hub. Now that IoT hub is useful for a couple things. One is you can connect to additional downstream devices using the same approach that you use in the cloud with IoT hub. The other is that we use message routes, that same routing functionality that I talked about before, where you can take inbound messages and route them to different endpoints. We use message routes for intra-container communication. So if one container, for example, is collecting data from a Modbus system, and it's sending it on to a stream analytics job, and then that's sending it along to a machine learning model to score it for stream processing, you can define all of that using routes. And the local IoT hub is what enables that. And so that summary of containers, the local routes, as well as IoT hub binding those, forms a deployment package. And as a deployment package comes down from the cloud, we place it on the edge. One of the things that we've done is also introduce this concept of a module twin. And what a module twin is, it's just like a device twin, only it's really geared towards controlling a piece of software or a module out on the edge, in this case in a container. Now, why did we do this? So a typical management example for machine learning on the edge is machine learning models often have a bunch of input parameters. And one of the things you do with machine learning is adjust the input parameters. And sometimes these machine learning models can be pretty big, half a gigabyte or larger. And if you're sending a gigabyte down and then you have to send another gigabyte down just because you wanted to tweak an input variable, that's kind of a waste. And so what we do is with each one of these containers, we have a module twin that's paired with it, that goes down with it. And the code in the container gets notified when the model twin's desired properties have changed. And so in this case, the machine learning model can simply adjust its input parameters. You can set that remotely in the cloud, and it'll automatically reflect down to the device. And then the container just turns around, or the code in the container just turns around, sets its reported properties in the model twin, and that flows back up to the cloud. So now I can see and remotely manage and control not just the workload, but the individual parts of the workload in the cloud. And then if I have additional devices connected, of course, we store offline device twins down in IoT Edge and mirror those device twins. And there's a topology relationship, so you can reconstruct topologies. So for example, I can tell there's an IoT Edge device there, and it's got these devices connected to it, and it's running these containers down on the edge. The hardware requirements are pretty low. Devices smaller than a Raspberry Pi will be able to run Azure IoT Edge with 128 megabytes of memory. And we'll support a bunch of operating systems, Linux and Windows for sure. And so we're pretty excited about Azure IoT Edge. I thought I'd do a quick scenario overview of what one of our customers, Schneider Electric, is doing both in the cloud and on the edge. So let me just switch over. So this is a pretty cool scenario that Schneider Electric has built. Just to set this up a little bit, water is one of our most precious resources. Fresh water is one of our most precious resources on the planet. Over 70% of it is being used in agriculture, which is a lot. By 2050, there's going to be a 50% increase in demand for that. And so every little bit counts. And the country of New Zealand has been sort of a leading country in terms of water conservation. And so Schneider Electric has been partnering with other integrating partners that they have in New Zealand to introduce a system that helps conserve water and conserve energy in farming. So let me just log in here. So what I can see as a farmer is I can see a heads-up view of all my agricultural installations. And in this case, I've received an alert, so I can drill into that. One of the things that this shows is the power of the cloud, where I can look at weather information, wind information, temperature readings, and I can aggregate all of that. Like, that's an entirely appropriate use of cloud, and it's not something that you do on the edge. So if I drill into this specific farm, what I see is that I have a wind warning. So a lot of these farms, they use they're a big circular plot, and they have a big watering boom that can sometimes be up to a mile long. And it turns out if a heavy wind hits those at the wrong angle, it can cause a lot of damage. And so I'll go ahead and investigate that. What I can see here is a heads-up view of all the different farms in this particular region. And one of the cool things that Schneider has done, and this is a live. This is a simulation, but this is a live deployed system that they've got in New Zealand that farmers are using. So one of the things that I can see is I can see wind speed for this view, but I can also drill into all of the different water tanks that are being used to hold water that I'm pumping out of rivers or pumping out of the ground. The New Zealand government places some pretty strict requirements on when these companies or when these agriculture companies can pump water and how much it costs and things like that. And one of the things that Schneider Electric did was they built some really sophisticated machine learning that takes a bunch of variables into account and finds the optimal time for farmers to pump water out of rivers or underground reservoirs. So for example, they take into account pending weather, whether or not it's going to rain. Like, why do I need to store water if it's going to rain? How much, there's sensors in the farms that measure how much saturation there is in the ground. And so how much water do I need to apply? How much energy, or what is the energy bill going to be if I pump water right now? Am I gonna trip over a period where it's cheap right now and then it becomes very expensive? And so all of this combined is helping farmers that have already deployed this save over 2/3 of the energy consumption that they were using already. So they've lowered their energy bills by 2/3 just by using the solution. So now if I drill into this particular farm, what I see is that I have an alert and there's pending water. One of the things that's cool about this as well is I can look at historical trends, so I can see moisture levels over time. I can also see plant root saturation. So what these deployments do is they have moisture sensors at 4 different depths, and they can tell how much saturation is happening. Like, is it just on the surface? Is it already, is the surface dry, but underneath the plants it's already wet? And the cool thing is that the boom that you see in the lower right-hand corner is equipped with some edge processing. And what that edge processing does is, as the boom is moving, it knows what sensor is underneath it and whether or not that plant needs water. And so it can turn on and off the nozzles on demand based on what sensor it's over. It also has cameras on it that can do some pretty sophisticated cognitive intelligence. And for example, what they'll do is if they're going over a ditch or some area where they're just going to lose water runoff, they can switch off the nozzle. And so they don't have to program that in. That's more adaptive and adapts to changes in the farm. And the reason why I like to show this example is it really highlights the cloud and the edge working in harmony. As an example, all of those sensor readings that are coming from those plants that are determining whether or not the nozzles turn on and off as the sprinkler is going, there's no reason to send all that to the cloud. That's totally appropriate to process on the edge, right? Like all that processing is happening local. And in addition, in case there's a local network interruption, this thing just keeps functioning and it keeps watering correctly. But historical data is then sent to the cloud and used to generate new machine learning models to further reduce the amount of water consumed. And I see I have an alert here. There's a high wind warning. And farmers can actually now remotely control these booms and move them into safe location ahead of wind events. So this is some of the cool things that our partners are doing with IoT and Edge. Finally, on the topics of security, Microsoft has a long history in security, as many of you know. IoT security is still an evolving field. And so something that we've done, we add all of the security, based on the knowledge that we have from over the years. We've added those techniques to our IoT offerings. But the other thing that we're very passionate about doing is helping the whole industry improve. So we recently published a paper. It's out here at aka.ms, WAC 7 Properties. And what it is it's a distillation of all of the learning that we've had over the years about how to keep devices secure. And it's called the 7 Properties of Device Security. And it's everything from hardware root of trust to small trusted computing base, to defense in depth and compartmentalization, to certificate-based authentication, to renewable remote security, and to failure reporting. What we've found over the years is that if devices adhere to these 7 principles and have operationalized these 7 principles, they can indeed be highly secure. They can indeed be threat resistant, and they can be healed if they are ever attempted to be breached. And so this is something that we're also standardizing. So we've taken it to the Trustworthy Computing Group, and we're taking this and standardizing it as something called the Device Identity Composition Engine, or DICE. The standards body decided on that name, not us, so I don't know that we would have called a security standard DICE. But that's what happens in security standards. Everybody gets a vote. But the bigger point is that we're passionate about improving security for IoT across the industry. What's neat is that Azure IoT Hub and our device provisioning service adheres to these principles, and so we support these principles. But we're really passionate about making sure that all devices, and really even all cloud services, adhere to these principles so that devices can stay secure. We have pretty comprehensive device-to-cloud security with a whole set of features underneath those, and we're always adding new innovations. An important innovation that we heard loud and clear from customers was something around security auditing. So oftentimes these IoT solutions are touched by many hands, right? There's multiple partners, there's multiple developers, and what customers have asked us is, how do I know whether this solution's secure? And so last year we introduced a security program for Azure IoT, and what this is a list of security auditors that we trust that are trained on Azure IoT technologies that customers can go and contract with. They will come, they will investigate whatever you make available to them. Oftentimes we have customers make their entire code base available to them. They'll find issues, recommend remediations. They'll make sure you're adhering to the secure development lifecycle. And if you're not, they'll help you. They'll explain how to do that. And so you can really help stay safe and find issues before the bad guys do. And then finally, we have a huge set of offerings for IoT, all the way from platform services to software services, and even the Microsoft Connected Field service, which is something that helps you service IoT devices in the field. And it, in fact, is already using Azure IoT Hub so that devices that are being serviced can call for help before they break. We have a bunch of great sessions all week today, or all week this week. And so you can see some sessions on Tuesday, Wednesday, and Thursday. We'll be going much deeper into Azure IoT Edge. We'll be going much deeper into trustworthy computing, device provisioning service, IoT Hub. So this was our overview talk that explains and sets up all of those, and they'll all go into much more detail. And with that, I'm going to put this screen up and then take questions with the time we have left, which is about 15 minutes. Sorry. Sorry, I couldn't hear you. Could you?
Have you seen any, thresholds for like the IoT hub where however many, if you receive, let's say, 1 trillion messages at one time, is there some sort of threshold where it starts to kind of break apart? What happens to messages that may be dropped, not recorded, not tracked? You know what I mean?
Yeah. Yeah, it's a great question. So the question was, are we seeing any threshold where IoT tips over, where you've sent too many messages to it or something like that? The way IoT Hub works is that there's, you provision it for the capabilities that you want. So for example, if I want a whole lot of capability, I can provision what we call a standard 3 SKU or an S3 SKU that guarantees capability for a certain number of messages per day. And so you can actually, it's basically a reserved model. And with that, we guarantee that you can send that amount of messages through per day. We do have throttling limits. So for example, if you were to try to use your entire quantity of messages in 1 second for that entire day, some devices will get throttled. And so what our SDKs do is they have exponential backoff, where they simply retry. And customers that use exponential backoff, you wind up, without being able to, you wind up not dropping messages, right? And so there's definitely a pattern to use, but we have a lot of headroom in these systems. The messaging infrastructure that IoT Hub is built on is processing worldwide 5 trillion messages every week. So it's and we're just going up from there. What else do people wonder? Yeah, and if you could come up to the microphone so everyone could hear you.
I have a question about the network bandwidth. Let's suppose a new company wants to implement this IoT thing for this manufacturing plant.
Yep.
So let's suppose they have like 1,000 of 1,000 or maybe some few thousand of IoT things that they are connected to internet. So looking at the previous example, so this particular devices are sending like every 10 seconds. So that kind of puts too much of pressure on my network. So are there any guidelines that says, okay, if I have like 1,000 devices, you need to have 100 Mbps, or maybe if I have 10,000 devices, I need to have more than that. So do you have any guidelines?
Yeah, so part of it's pretty easy to figure out how much bandwidth you're going to consume and to decide whether or not you actually have the network pipe for it. One of the things that we do recommend, and it's why we're investing on Edge, is that there's a lot of scenarios, especially where you have constrained connections, there's a lot of processing that can be done on the edge. And so if you don't have bandwidth capabilities, you can do things like store and forward and then do bulk uploads. You can do things like process on the edge. And so it's very highly solution dependent, but that's a big reason why we're investing in Edge, so that you can process these things on premises.
Okay, thank you.
Yep, sure. Yep, another question.
So I'm from a fleet management company.
Cool.
Currently we are managing around 100,000 vehicles.
Okay.
Every day we insert around 60 million rows. Everything is on premise.
Yep.
So we're trying to see what are our possible options in cloud.
Yeah.
Seeing in the future, what do you suggest the best solution could be for us?
Well, what are you sending?
So
like what type of data are you sending? And how frequently?
It's the same sensor data. We have like around 30 vendor integrations. Everybody sends their data through API. We just get the stream, process it using service bus pattern, and store it in Oracle database as of today.
What are you storing it on-prem with today?
On Oracle.
On an Oracle database? Okay. So there's a lot of options you could do. it sounds like it's time series data, so Azure Time Series Insights is definitely a great option for that.
Okay.
We support some rich database models as well. So we have SQL Azure if you need transactional support, or if a NoSQL store is more appropriate, we have Cosmos DB. One of the things that's interesting with Cosmos DB is that it supports georeplication. And so you can basically have a worldwide database. It's a worldwide NoSQL database. And so if you have different parts of your fleet inserting rows from different parts of the world, you can do that. Okay. But that's an eventually consistent model as opposed to a transactional model like SQL. But we see a lot of customers picking up time series insights now that it's in public preview and soon to be GA.
So for ingestion or storing the raw data, you prefer Cosmos DB, and for doing any kind of transactional or...
And it depends. Part of the answer to your question is going to depend on what are you doing with the data. Are you simply looking for little thresholds? Are you doing...
No, we have many KPIs and alerts based on that.
Yeah. And how quickly does the data need to be processed?
So our SL is 15 minutes. Any event happened on the road should be displayed on the web in the 15 minutes.
So a common pattern for that is using something like Azure Stream Analytics for hot path data, we call it. Something that needs to be processed in near real time. Like as soon as it comes in, I want to process it and look for anomalies or look for certain thresholds being met, and then to be able to signal some event. Like, hey, this just went into a geofence region that it shouldn't have. So Azure Time Series Insights Azure Stream Analytics supports geofences as well.
Yes.
And so you can use it for alerting when it's inside or outside a geofence and things like that. So that's a great store. But if you're looking at historical data and running machine learning on it, Cosmos DB, Azure Time Series Insights, those are great options too.
All right. Thank you.
Cool. Anyone else? All right, thank you for coming. Appreciate it.